Hello, geometry students. Here's your lesson for section 8.3, solving right triangles. Missy McCarthy, Okemos High School math instructor. In this lesson, you're going to use all of the trigonometric ratios to find angles in right triangles and to solve some real-world problems. So here's just a brief reminder of the trigonometric ratios that you learned in class yesterday. Sine, cosine, and tangent, where sine is opposite over hypotenuse. Tangent is adjacent over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I may have misspoke there, but you can see the diagram, and you should remember SOHCAHTOA from the previous lesson. So in this particular example, we're just applying what we know about SOHCAHTOA. And we're trying to figure out, if you're given that the trigonometric ratio is 8 over 17, which one of these angles must be angle A? Is angle A going to be located here? Or is angle A going to be located here? So as I think about this, I try to figure out which ratio is going to be equal to 8 over 17. So if I divide 8 over 17, 8 divided by 17 is approximately 4.47. So if I place my angle A here and I do opposite over hypotenuse, am I more likely to get 0.47? Or if I place my angle A here and I do opposite over hypotenuse? Well, 27 over 30, that's way bigger than 0.47. So my guess would be that angle A would be here. So let's try it. If I do sine of angle, I'm going to call it angle 2, I would end up with opposite over hypotenuse. And if I divide those two in my calculator, I'm going to get approximately 0.47, which means that angle A is at angle 2. Now for the second one, again, we're trying to figure out where angle A is. Do I want to put angle A here or angle A here? Well, I know when I do the tangent, when I do the opposite over adjacent, I need to get 1.875. So if I position my angle A here and I do opposite over adjacent, that's going to give me 27 divided by 14.4, which is 1.875. So I know this is not angle A, and I know that angle A is at angle 1. Now, what if I wanted to know how big angle A was? What if I wanted to know the measure of angle A, its actual size, its actual degrees? Well, I would have to use what we call an inverse trig function. So here it says, if you know the sides, can you find the angles? So it says, if you know the sine and the cosine and the tangent of an angle, you can use what we call an inverse trig function to find its measure. Similar to if you know the perfect square, how you can take the square root to find out what the number is. Those are inverse functions. We can do the same thing with our trigonometric functions. So if you look here, it says, if the sine of angle A is equal to x, then the inverse sine of x is equal to the measure of angle A. So if you're given the angle, you can find the trigonometric ratio. But if you're given the ratio, you can actually also find the angle. So let's take that most recent example we had where we knew that the tangent of angle A was 1.875. If we wanted to find angle A, we could say the measure of angle A is equal to the inverse tangent of 1.875. Now to do inverse tangent on my calculator, I am doing second, pressing the second button, and then tangent, and then 1.875. And I'm telling it that my ratio is 1.875. What's my angle? And if you press second tangent, it gives you inverse tangent, plug that in, press enter, and it'll tell you that that angle, I'm going to put approximately here because I'm going to round, is approximately 61.9 degrees. So let's just practice doing the inverse tangent of 0.75 to find out the measure of the angle. So that angle would be, that angle would be approximately 30, it says to the nearest degree, so approximately 37 degrees. I can do second cosine, inverse cosine of 0.05. And that angle is approximately 87 degrees. And then do inverse sine, second sine of 0.67. And that angle is approximately 42 degrees. So let's see if we can solve this real world problem now that we know how to find angles. So the problem says it's a hill in the Tour de France with an 8% grade. To the nearest degree, what's the angle that the hill makes with the horizon, or with the horizontal line? So here's my horizontal line. And what does it mean to have an 8% grade? Well, it tells you something about the rise over the run. It says for every 8 units it rises, it runs 100. So 8 over 100 is equal to 8%, or 0.08. So the angle we're looking at is right here. What angle, this one right here, is the road surface, so here's our road surface, making with the horizon. So I know that we have the 8 over 100, which is opposite over adjacent. So that tells me I'm using tangent. So I know that the tangent of angle A is 8 over 100. And then to find angle A, I have to use inverse tangent. The inverse tangent of 8 over 100. And let's see, let's find that angle. Inverse tangent of 8 divided by 100. So it looks like that angle is about 4.6 degrees. And that makes sense that it's going to be a tiny angle if the rise is only 8 to a run of 100. All right, so our last concept here is what we need to do to do what is called in math, solve a right triangle. So to solve a right triangle right here, it just means to find all the missing sides and the missing angles. That's what it means to solve a right triangle. So here we know side AB is 42. We know, I'm going to put a C right here, that BC is 31. We do not know what AC is, so that's something we have to find. We also don't know the angles, angle A, and we don't know angle B, but we do know that angle C is our 90-degree angle. So there's 3 things that you want to keep in mind when you're solving any right triangle. The one thing you want to keep in mind is the triangle sum theorem, which says that all of the angles add up to 180, or one of the corollaries that says the 2 acute angles add up to 90. The second thing you want to keep in mind is the Pythagorean theorem. If you have 2 sides and you want to find a third side of a right triangle, that's the way to go. And then the third thing you want to keep in mind are your trigonometric ratios and inverses, because using those you can find missing angles. Okay, so the very first thing I think I'm going to find is AC. I'm going to use Pythagorean theorem to find AC. We've got 31 squared plus AC squared equals 42 squared. So 42 squared minus 31 squared, that gives me AC squared equals 803. I'm going to take the square root of both sides, square root of both sides. And I know that AC is approximately 28.3. So we found one piece of missing information. Now the 2 things that they gave us, let's look in reference to angle A here. They gave us the opposite of angle A, and then we also have the hypotenuse. So I can use the sine, because sine is opposite over hypotenuse, of angle A, and I know that's 31 over 42. So to find the actual measure of angle A, I'm going to use my inverse function. So the measure of angle A is equal to the inverse sine of 31 over 42. So inverse sine of 31 divided by 42. And you get the measure of angle A is approximately 47.5. degrees. And then to find angle B, I'm going to use the triangle sum theorem. So I've used Pythagorean theorem, I'm going to use triangle sum theorem, I've used my trig ratios to do 90 minus 47.5 to get 42.5 for the measure of angle B. So we'll practice more like this in class, but remember to solve a right triangle. All you need to do is find all the missing sides and missing angles. See you tomorrow.